Okay, guys. I was doing some thinking on this intake manifold, and I was a little surprised that someone didn't say something about changing the runner length or changing the curve at the top and therefore changing the reflection point of the wave. I put some marks at the top of those runners. Notice how much taller one is than the other, right? It's interesting. The one on the right is number 3. That's much shorter, and it's a shorter runner, and it's not as tall. Okay? So what I did is I was thinking about the RPM bands of this manifold and where the tuned lengths and so forth. You know, the Chevy runners are right next to each other. Therefore, they're much closer in length, right? Okay. We've got 4 different length runners on this. I measured them all, and they're... let's see. 5 and 4 are practically identical. 6 and 3 are practically identical. 7 and 2 are practically identical. And 8 and 1 are practically identical as far as lengths go. Also, the way they're cast into the manifold. I mean, if you look at the heights of these 2 runners, right? And then I flip the intake over. Okay? It's really the same thing. And I didn't realize it when I was developing it, but this runner has a slight curve to it, right? This one is completely straight. This one's got a slight curve to it. This one's completely straight. And even the divider between the 2 long ones. I took more metal out of the right side on that divider. Where are you? Took more metal out of the right side of that divider. So, I was thinking, I would like to calculate where these 4 different length runners are tuned for. And I had to do a bunch of guesswork in order to do that. I used 2 different calculators, and they were both pretty close. And I need you guys to know that I am certainly not a Helmholtz resonance intake manifold tuner expert by any stretch of the imagination. Okay? In fact, it was never really part of my engine tuning regime because depending upon the RPM range, I either ran a single plane or a dual plane. Didn't have enough money for tunnel rams and dual carbs and all that cool stuff. So I was stuck with where my RPM range is, and I really couldn't worry about that much. But this is going to be going on a drag racer. He's going to be spinning it pretty good. He originally was only bringing it up to 5,500, and I said something about it not being a tow truck. I don't think he laughed. He said, yeah, he did bring it up to 6,000 a couple times, and it was faster down the strip. And I said, that makes sense. So he's taking the short block apart, and he's going to do some work to it, and I think our new RPM limit will be 7,000. Now, 7,000 for a 5.0 Ford is not a problem. Okay, if you take it apart and you do your deburring and so forth, like I showed on another video, it should be... a 302 Ford is pretty stout. Okay? I mean, even stock, it's pretty damn stout. And we went over why it breaks at 500 horsepower, or if it does. I wonder if those were... It's almost like the harmonics built up at a steady RPM and caused it to fail. But I'm getting around things. This is more of like a thought-provoking than an actual lesson, because I don't have the answers, and a lot of this is estimated. So I don't want, the really geeky guys that I have on here to say, Charlie, you goofed up that calculation by 100 RPM. I don't care. This is just to get an idea. Okay? Now, measured the runners, right? 1 and 8, about 7 inches. Now, how did I measure them? I stole one of these from my wife. I said, I need this, and it's going to be dirty, so you're not getting it back. And I ran it along the top of the runner right to those magic marker marks where I thought the pulse would end. Okay? See those marks right there? That's where I'm thinking the pulse would reflect back to. Am I right? I don't know. I'm estimating. Okay? So I did that on all of them. So 1 and 8 are 7 inches. 2 and 7 are 4.5 inches. 3 and 6 are 3 3/4 inches. And 4 and 5 are 6.5 inches. Okay, so I did some calculations, and this is close to where they're going to be. And I'm thinking that it was originally designed for 4th harmonics. I don't know what it was designed for. Maybe there's an engineer from Edelbrock that designed this manifold, and he knows what it was tuned for. I'm guessing it was 4th. Okay, because it's advertised as an intake that's good for 8,500 RPM. Okay, well, if it's good for 8,500 RPM, you want to tune the torque peak between 1,000 and 1,500, less than that. If that number is incorrect, please correct me, guys. That's where I think it should be. Okay, so 1 and 8 tuned to about 6K, 6,000 RPM. 2 and 7 tuned to 7.6 thousand RPM. 3 and 6 tuned to about 8.3 thousand RPM. And 4 and 5 tuned for about 6.3 thousand RPM. Okay, now somebody's going to say, how can that work? You've got 4 different length runners, all tuned for different RPMs. Okay. Not the world's greatest drawing, okay? But I hope it proves a point. Now, only pay attention to the X's with the circles. I wasn't going to redraw it. I'm way too tired tonight. Okay, the longer runners... I was asked to use a pointer, and now I can't find my damn pointer. So, okay. Longest runners are tuned for the lower frequencies, okay? So 1 and 8 have the longest runners. They're tuned, I think they tuned out right about 6,000. 6.3. No, 6,000. 6,000. Okay. And the next set of runners were only a little bit shorter. They're 6,300. Okay. Next longer runners tuned to 7,600, 2 and 7, and then 83. Now, if I drew this out, okay, not great as far as my drawings, but hopefully you get the idea, right? You've got literally 4 different torque curves. Because of the different runners tuned for a different length, they'll work best at that frequency. Now, does that mean they can't go above and below that frequency? Of course they can. They just lose a little Helmholtz pulse, adding to the what do they add to, guys? They add to the ramming effect, right? Okay. So literally, why I never worried about this when I was younger, and I don't worry about it now, is if you have multiple torque peaks, kind of just like that Edelbrock Performer intake manifold with the smaller runners and larger runners, it's the same idea, right? What you wind up doing is you flatten the torque curve out. It doesn't just peak at that 1 RPM anymore. It peaks at multiple RPMs, depending upon which cylinder's firing. And it flattens out the whole torque curve. Now, if they were all the same length, it would probably peak higher, but it would only peak at 1 RPM. If you could get them all equal length, like on a tunnel ram, right? You can get all 8 of your runners right on the money and have it peak at a certain RPM. So I wanted to bring this up as more of a discussion than anything else. I realized in order for me to get these, I had to estimate a few things. Okay, I had to estimate, depending upon what calculator I was using. They wanted to know, the advertised duration, the intake valve closing degrees, the compression ratio. We know what the bore is. We know what the stroke is. We know what the rod length is. And then we have to put in the RPM. And I guessed at the advertised duration and the lobe center, because chances are this is going to, after I'm done doing the heads and getting some flows, we'll have somebody that really knows camshafts make up a cam that'll really fit it well. And I'm estimating what I think they will figure out to put in it. That doesn't mean I'm right. All right, guys. I know I spent way too many hours out in the sun today. That's why I'm more burnt than usual. But I was really expecting somebody to say, you completely ruined this runner by putting a sharp edge there, or something like that. Now, of course, I did that to equalize the flows. But if you think of it according to this, and I left them round, what does that do to the peaks? The higher flowing short ports would have taller peaks, right? And the lower flowing long ports would be lower RPM and lower torque peaks. So what it would kind of do is take this whole curve, kind of put it on a bit of an angle, right? Interesting to think about, right, guys? So nobody said I totally screwed this up, which I was kind of expecting. I'm trying to get as even an airflow through each cylinder as I can. Now, will that help it make more power? I think it does. I may not be right. If you know for sure, please comment. So far, our comment section has been really, really great. And some of the guys that have gotten in touch with me have been phenomenal. I've got one guy who's talking to some really top-notch guys in the industry, and they're giving their input, and that's awesome. That's awesome. Unfortunately, when he tells me that I should be getting a lot more out of this than I am, I'm like, all right, back to the drawing board. Oh, I did want to show you guys one thing. As far as getting the length of your intake ports, let's see if you can see how that is. I like to use a piece of piece of solder like you would solder water pipes with, right? If you can see the end, right? And then over here, you'll see there is a little Sharpie mark where the valve would touch the seat. And you bend it to fit into the port, right? Then you pull it out, you straighten it, and you use your caliper, and that'll give you the length of the roof. You do the same to the short side. Do the same to your short side. You can see the mark, right? You straighten it out, and you use your caliper to get that measurement, and you average those two measurements. That'll give you your lengths. I probably should have done the same thing to the intake manifold. I didn't think about it. Yeah, this paint on my thumb. The wife had me painting the house today. What a joy. In the billion-degree sun. So, I didn't really get a ton done. I actually got to do a little bit of work on the GT40s, the 3 bars. I think they're coming along very nice. I'll get some flows hopefully on them tomorrow. And I want to get the GT40Ps on the bench with the intake and see how it does. Alright guys, thanks a lot. Appreciate you guys hanging out with me. Thanks.